Lesson 21B, we are actually beginning Unit 4. Some of the stuff during this week will essentially be some review of some things that have been on our X problem worksheets. In other words, all this exponent stuff. So we'll do some of the review stuff, but then extend it out a little further. So that's why the content objective says review exponent ideas, at least for today. From grade 7. And we'll talk about ways of breaking apart the expressions. May even be a little differently than you've done in the past. So let's go ahead and get started here. Each of the following problems involve basic exponent ideas. Answer each to review your previous knowledge. So what if you were asked to represent 6 to the third power as an extended product? What does that mean, extended product?
I'm sorry.
Okay. Cambry?
I'm just trying to get a guess, but I read the extended, you're writing it out.
So what would it be?
6 times 6.
Times?
I said...
Oh, you said it first and then I didn't hear? Okay, yeah. That's what extended product means. And we may want to make a little note because today we're going to keep coming back to this idea of extended product. So when I say the two words extended product, that's what I'm referring to. Writing it out, but in this case, not evaluating what it is when you multiply it out. Sometimes we will, sometimes we won't. But when I refer to extended product, that's exactly what I'm referring to. All right, part B. This is something we did earlier in the year. If f of x equals 2x cubed plus 7, then f of negative 1 is equal to blank. Go ahead and evaluate that function. All right, so for those of you who've forgotten how to evaluate functions, basically we are substituting in for x negative 1. X is being replaced by negative 1. So what that means is we need to substitute negative 1 in for x right there and then follow the order of operations and simplify. So f of negative 1 is equal to 2 times negative 1 cubed. Following the order of operations, negative 1 cubed is negative 1, so we have 2 times negative 1 plus 7, and that, of course, is negative 2 plus 7. So f of negative 1 is equal to 5. All right, next, part C. If x cubed times x to the 5th is written in the form of x to the n power, what is the value of n? And if you don't remember the rule of how to deal with multiplication of things with the same base, then write it as extended products. What I meant by writing extended products, if you don't remember the rules, you just have to go back to the basics, and I will be going back to the basics of exponents a lot over the next few days. You will rarely hear me talk about a specific rule because as soon as we start doing rule after rule after rule after rule, some students tend to get them all mixed up. So we're always going to go back to the basics. X cubed is x times x times x. That's the extended product. X to the 5th is 5x's. And as you can clearly see, we have 8 of them that we are multiplying together. So that simplifies to x to the 8th. So that means that n is, of course, 8. All right. Let's see what you come up with for part D. If the expression 5x cubed, all of that to the second power, is written in the form ax to the b power, what is the value of a plus b? So you'll have to simplify 5x cubed, all of that to the second power first. So if we have 5x cubed to the second, that means 5x cubed times 5x cubed. 2 of those. And now, from there, this is where most of the people tend to just jump and do all the work in their head. And that's fine, but if you're going to do that, you need to think about things in terms of maybe the commutative property or the associative property. So most of you, I think at this point, probably multiply the two coefficients in your head. That would be an example of the commutative property. So the first thing we did is we wrote this out in terms of the extended product. And then we, in our head, usually rearrange things. That would be either the commutative or the associative property. Thank you. Depending on how you look at that. And then that becomes 25x to the 6th. Now, a little bit later in the lesson, I'm going to be asking you about what rules that or properties that we've used, so be prepared for that. All right, so in this problem, it's not asking us for the simplified version. It's asking us what a plus b is, though. What's a plus b? It's 31. A is 25, and we're basically looking right here. A is 25 and B is 6, so that would be, of course, 31. All right, let's continue on. Part E, and I have asked problems similar to this in the X problem. It says, if the length of a rectangle is 3 times 10 to the 5th, and the width is 2 times 10 to the 4th meters, what is its area written in scientific notation? So if we have a rectangle, to find the area, it is always the length times the width or the base times the height, depending on how you look at that. So if we multiply those together, that would look like this. Now this looks similar to a problem that you see every single time we have X problems. Finish it from there. Make sure your answer is written in scientific notation. Here, much like one of the previous problems, or the previous problem, we can rearrange things in our head. We could use the commutative and associative properties together to rearrange, put the coefficients together, and then the bases and their exponents together. 3 times 2 is 6, and 10 to the 5th times 10 to the 4th is 10 to the 9th. And once again, this is the commutative or associative properties right there. So that's 6 times 10 to the 9th square meters for the area. Okay, so let's continue on here. Yes?
When we got 6 times 10 to the 9th, did you want us to simplify it further?
No, because it says write your answer in scientific notation, so we're good. All right. Part F. I would like you to try this one all the way through. So here's what I would do. First of all, I would start with extended products. So we have 3x to the second times 3x to the second. That comes from this part right here. And then we have 3 of these 2x to the 5ths, and that's where we get this part right here. From there, we could do a little bit of work by moving things around using the commutative property. And that would, I just took the coefficients and moved them together, because what a lot of you do at this point is you take and just multiply them all together, which is essentially what we're doing right there. And then, of course, sort of group all of those x's together. But regardless, we end up with 9x to the 4th times 8x to the 15th. And then the 9 times the 8 is 72. And x to the 4th times x to the 15th is x to the 19th. So 72 x to the 19th. Any questions with this one? Yes?
I have a question, but I have no idea what I did.
Okay. What did you get?
54x to the 12th.
54x to the 12th. What did you get? Did you do some sort of work with this?
What are you referring to?
Okay, so that was a bunch of things that involve multiplying. Now we're going to go into some division. And I just want you to bear with me on a few of these problems, because I'm going to show you a different way of looking at them, and then I'll show you why that's really happening. So it says here, we also would like to be able to write simpler equivalent expressions involving division problems involving exponents. This all comes down to your ability to what I call unmultiply fractions. And what I mean by that is I want to break this up right here into a fraction times another fraction. And what I want to do is I want to break that up so that I can create right here a fraction that represents 1, or it's the same thing as 1. And I want to pick the largest things that I can pull out from the numerator and the denominator. And in some respect, that's kind of like the greatest common factor. So if we look at, first of all, the coefficients here, what's the greatest common factor between 2 and, I didn't mean to highlight some of the x's there, between 2 and 4? What's the greatest common factor between 2 and 4? It's 2. All right, so let's go with a 2 here and a 2 here. And then now let's take a look at the x to the 6th and x to the 2nd. What's the greatest common factor, or the largest thing that goes into both x to the 6th and x to the 2nd? It's what? It's x to the 2nd. So what I've done here is I've created the largest things, if you want to call them things, that go into both the numerator and the denominator. Now, if we pulled away from this, and now it's a big mess. Let me do some erasing here. What's left once I pulled out the 2x to the second from that? It's x to the fourth. Good. Once I pull the 2x to the second out of this, what's left? It's what? It's 2. Now what we've done here is we've created, by unmultiplying, I've created a fraction that is equal to 1, and what's left is times x to the fourth over 2, which means that simplifies to x to the fourth over 2. Now I already know what some of you are thinking. Well, isn't it much easier to just do this? You're right. But what's happening when you are doing what you typically do is you are doing this step, once again, in your head. You are actually reducing the numerator and denominator in this problem by 2x to the second. That's really what's happening. So what I'm saying, one more time, is this. If we create a fraction equal to 1, we get this. That is a fraction equal to 1, and so this ends up being x to the fourth over 2, because this is really 1. Now another way of looking at it would be like this. If you thought of the numerator as a prime factorization, and same thing with the denominator, you are reducing the numerator and denominator by 2, and then by x, and then by x. And if you took those yellow things that I just highlighted, essentially what you have is this right here. Now we're going to do a little bit of practice with this, trying to create this fraction of 1, because what this does is this tells us that this is what we are reducing the numerator and denominator by when we do these things in our head. So let's do a little bit of practice of this. Let's try number 1, part A. I want you to create two fractions. We're doing a little bit of unmultiplying here, such that this first one is really 1. Let's give that a shot. So I had talked about a different way of looking at A, which is still left on the screen there. If you're not sure how to deal with B, go back to extended products. X to the fourth is x times x times x times x. And on the bottom, I'm already tired of writing all of these x's. At some point, we have to kind of see what's happening there. And right now I have 7, 8, 9, 10. And what happens here is that we have all of this happening. 4 of them on top. Cancel out, if you want to think of it that way, with 4 of them on the bottom. And somebody asked, well, why is it 1 over? Well, you should see right there. We have 1 times 1 times 1 times 1 on top. And on the bottom, we end up with x to the 6th. This part right here is the creation of your fraction that is equal to 1. X to the 4th over x to the 4th. And then we're multiplying that by 1 over x to the 6th. So if you get stuck, that's one way you could go back and try and figure that out. But if the instructions do tell you to do this, and in the homework most of them don't, but there are a few that do, you need to make sure you give me these pieces before you give me the answer. Okay? And then part C, we would break that up into x times y to the 8th over x times y to the 8th. Remember, that first part ends up being 1. Those are both the largest things that go into both the numerator and the denominator. So that simplifies, obviously, to x cubed over y to the 2nd. So any questions with either B or C? All right, let's keep going here. Number 4, simplify using repeated multiplication and fractions equal to 1. So we're going to go through this one together, and then I will have you try part B. So in the numerator, I would write that out using extended products, like that. Then, for me, I would, in my head at least, use the commutative property and gather all of the coefficients together and gather all of the x squareds together. Once again, that's a combination of the commutative and associative properties. And then the 3 times 3 times 3 is 27. And we're talking about on top. On the bottom we have, or excuse me, n times x to the 6th. And then we end up with this. And I'm going to let you finish using the fraction equivalent to one thing. Go ahead and finish this problem. So we end up with 9x to the 4th over 9x to the 4th times 3x to the 2nd over 1. So that simplifies to 3x squared. All right, go ahead and try part B all the way through. Okay, first of all, I would use extended products to write it out like this. And remember, in the homework, there will be a few problems where it's going to ask you what you are doing. That's extended products. From there, I would regroup everything, put the coefficients together, put the x's together, put the y's together, and so on. That is a combination of the commutative and associative properties. And from there, you can simplify. And then the largest thing that will go into both the numerator and denominator would be 25x squared y squared. That creates my fraction of 1. And that is what that's called when we're doing that, creating a fraction of 1. And then so that's 1 times x squared y to the 4th over 4. And that is x squared y to the 4th over 4. Last thing for today. There are some problems in the homework where it's asking you for the rule or for the property or something like this. I'm just going to go ahead and tell you these because we're almost, we've gone over a little bit further. We've gone a little bit further than I wanted to as far as time goes. So the first part right here is extended products. Go ahead and write that in, fill that in. Second part would be commutative and associative property, and this is almost like every single problem has been. And then we're creating a fraction written as 1 there, and then of course we simplify to get the answer right there. All right, we are finished for today.